As director of the Proteomics Core, we have several collaborations with industry and academia. My perspective as a proteomics scientist, I want to identify the whole proteome. I want to be able to detect all the potential proteins, all the post-translation modifications that are there. We have different types of projects, including biomarker discovery, protein-protein interaction, and protein profiling. We recently established a collaboration with Seer to test the Proteograph platform. We evaluated the performance of label-free proteomics against TMT analysis, combined with the Proteograph. The Seer workflow provides a high-throughput sample preparation platform. The Seer technology allowed us to prepare up to 16 plasma samples in a single day. We thought that was a great match for the TMT technology. The whole mass spec analysis took 2 days. Currently, most of the workflows for analyzing plasma samples use either direct analysis of the plasma, which has a really low coverage of the proteome, about 300 proteins, or use immunodepletion, which is very time-consuming. Our main goal in this study was to improve the plasmaproteomics analysis. So we tested different platforms. By combining the Seer technology with the TMT labeling, we could get a better coverage, better throughput, and better reproducibility. Our workflow found about 3,000 proteins in the plasma. Also, our CVs were really good. We found about 15% CV, and we could cover about 9 orders of magnitude in plasma. Found a number of different proteins that are known to be low abundance, such as cytokines, hormone activity proteins, GPCR receptors, and so on. For years, the proteomics field is thinking or trying to find a way to get over, this huge dynamic range problem that we have in the proteome, in the plasma, the biofluids proteome. We have tried many different technologies. We have tried fractionation, we have tried immunodepletion. We typically get about 6 orders of magnitude with immunodepletion. With the Seer technology, we increased that to 9 orders of magnitude. I think the Seer technology is a game changer in this way. The proteomics field is promise in the personalized medicine in terms of finding biomarkers and developing biomarkers for different diseases, for different cases, and will allow proteomics to help in other areas of clinical and biomedical research. I think it will allow us to finally take on these large studies. Most of the proteomics study with large cohort is done with single-shot proteomics, which only cover about 300, 400 proteins at most. So this will be very different. We'll be able to look at 3,000 proteins with a very similar throughput of the single-shot proteomics. Today, the proteomics field has a problem with balance between throughput and coverage. I think the Seer platform will finally allow us to bring these two things together, the throughput and the coverage of the proteome. What excites me is finally being able to see all these low abundance proteins that are known to play a role in disease and health state. That's what my dream out there.